Hi, my name is Oanh, and I'll be presenting on the effects of ketamine on healthy and stressed rats. Anhedonia, which is the loss of pleasure from previously rewarding activities, is a cardinal feature of several neuropsychiatric conditions. It's commonly associated with major depressive disorder, but also deeply indicated in bipolar disorder, schizophrenia, and substance use disorder. Unfortunately, even for those clinical populations where typical antidepressants such as SSRIs are effective, they do not restore hedonic tone. However, the NMDA antagonist ketamine appears to offer both rapid antidepressant effects and prohedonic effects in treatment-resistant clinical populations. So we're examining ketamine in healthy rats to further validate our animal model of reward sensitivity and extend it using an ecologically valid chronic stressor. The human task employs visual discrimination methodology with asymmetric probabilistic contingencies arranged in a 3-to-1 ratio of reinforcement. For example, correct responses in the presence of the long line are 3 times more likely to be rewarded than correct responses to the short mouth. As expected, a response bias would emerge in favor of the rich alternative for healthy subjects. Our lab specializes in touchscreen methods, and we've reverse translated this test for laboratory animals that also require discriminating between line lengths. This approach is quantitative based on the matching law and signal detection theory, which yields key metrics. First, response bias, or log B, which measures the tendency to respond to the more richly rewarded stimulus, and discriminability, log D, or task difficulty. This capstone paper shows healthy human controls developing that large response bias across session, whereas patients with MDD have blunted log B values. Unstressed rats demonstrate log B values for control and vehicle that closely approximate human outcomes. 2 hours after injection of ketamine, we see a dose-dependent increase in response bias. However, those effects subsided by the 24-hour time point. Importantly, these increases in response bias were observed following doses of ketamine that did not perturb log D. We investigated a variety of commonly used stressors in the rat. One that worked well was exposure to chronic inescapable cold water. For subsequent studies, we chose 14 degrees Celsius since it was the highest temperature in which all rats submerged. Compared to pre-stress baseline values of log B here, we observed a blunted log B after an average of about 3 days of stress. It was rescued following 10 mg/kg of ketamine at 2 hours, and it approximated control values 24 hours after injection, reaching statistical significance. No perturbations in log D, which means these response biases observed were not simply a function of degradation of task performance. In conclusion, we successfully extended clinical findings to our animal model and further validated a chronic stressor model to allow us to blunt response bias and subsequently rescue it following ketamine treatment, which is important in the pursuit of discovery of candidate therapeutics. Thank you for your time. Let me know if you have any questions.